In the previous course, you learned some documentation best practices in paper-based systems. You learned the different phases of data processing, from initial creation to final destruction of papers, that form the documentation data lifecycle, according to data integrity and Alcoa Plus principles. While the principles of GDocP and data integrity apply equally to paper-based, electronic, and hybrid systems, regulatory agencies do not place any restraint upon the adoption of new technologies. Why is that? The reason is simple. Paper-based systems are not always appropriate. Manual processes can be suitable for small companies with minimal personnel. However, as systems grow increasingly complex, electronic controls become more important from a data integrity perspective. This is because electronic and hybrid systems are more robust and secure than their paper-based counterparts. Whatever approach you choose, you will want to make sure it aligns with the complexity of your system and resources. If you decide to adopt GDocP for electronic systems, congratulations, you've made the best decision. Sooner or later, manual processes will be replaced entirely by innovative technologies and continuous improvement tools, which are fundamental to any well-designed quality management system. In this course, I will show you some best practices for keeping electronic records in a compliant manner. You will learn how to implement GDocP in electronic records with different real-world examples. Manual processes are transitioning to electronic ones. The life sciences industry is no exception. Computerized systems, for example, EQMS, EBMR, DMS for chromatography, etc., are available for the creation, review, and issuance of documents in electronic form. They work efficiently and securely. The first requirement is to have all your computerized systems qualified and validated. Secondly, you need to have a clear understanding of the data governance requirements. To properly manage electronic data, you will need suitable systems and the use of novel technologies that enable the proper control and security measures of electronic data. I will not discuss the technological aspects of electronic systems in detail, but it is important that organizations maintain appropriate resources for managing electronic systems. Resources are needed to design, develop, operate, and monitor the data governance systems in line with the complexity of data management processes, data integrity requirements, data criticality, and risk. Regarding data criticality, you have to ask yourself, what is the impact of the electronic data on the quality of my products or on safety? Regarding data risk, you must ask yourself, can the data be altered involuntarily? Can it be deleted, lost accidentally, or even deliberately falsified? You might also consider whether your system has controls in place to detect these actions. Keep in mind that data integrity gaps are not limited to fraud or falsification. They can be unintentional and still pose risk. To answer these questions, you need to perform and document a complete risk assessment. How can you start? First of all, you should concentrate on every single business process and map out the flow of data. For example, you can map out how analytical data flows from sample reception to final release for a specific batch in quality control. Another example is the flow of data from the issuance of a batch record until the final approval of a batch of product manufactured in production. Accordingly, a good way to detect the risks of electronic data is to evaluate how data flows and the methods of generating, processing, storing, and archiving electronic data. The degree of automation and human interaction are other important factors to consider. Data manipulated by technology can be validated, but data manipulated by people is more prone to error. Our recommendation is to mitigate the risks of people performing errors by automating processes as much as possible. Otherwise, you will need to implement a robust systems of oversight and secondary review. Now let's discuss how to manage electronic data through the electronic data lifecycle. Remember, the only employees with specific roles and skills should have privileges to generate data on electronic systems. Not everybody can do everything in GXP environments. An electronic system can store predefined templates to ensure uniformity among different types of documents, SOPs, work instructions, forms, etc. The content of each template depends on the intended use of the document. If electronic templates need to be used, access should be controlled, at least by username and password. Good documentation practices are also applicable to electronic data. Data should be entered contemporaneously at the time the work is performed. Remember that the principles of Alcoa Plus we discussed in the previous course also apply to electronic systems. Once data is recorded, some electronic systems can process raw data captured into more accessible and usable formats. For example, a supervisory control and data acquisition, SCADA, is a system of software and hardware elements that allows us to monitor, collect, and process real-time industrial data from sensors, valves, pumps, motors, etc. Another example is an electronic quality management system platform, which captures timestamps for different quality processes. For example, document control, events, CAPA, training, instrument qualifications, etc., so that readers can visualize statistics and graphs for KPIs. If you have hybrid systems that use both electronic data and manual data in their activities, you should describe all the systems that are electronically controlled in an SOP. In the event of an electronic record is generated in addition to a paper document, you should determine in advance whether decisions are made using electronic records or paper-based records. This needs to be clearly described in the SOP. The audit trails of all data generated from a computerized system should be reviewed regularly. Although electronic systems must be validated beforehand, you need to identify whether the data has been processed as expected. You must prevent any incorrect results that occurred after processing from being reported, and also from being hidden or deleted. In short, audit trails need to be reviewed before batch release, or regularly reviewed at other junctures, with the frequency depending on your data integrity risk assessment, DIRA. Users should not have the ability to amend or turn off the audit trail functionality. After review, all GMP documents should be approved by manual or automatic means before use. For example, GXP documents are usually approved by quality assurance. The data life cycle of these documents should be managed by means of the change control procedure. Whenever someone signs electronically, the name or ID of the person should be printed, as well as the date and time. The intent of the signature should also be visible. Signing means that the person is accountable for the corresponding information. Documents that are issued electronically upon approval can be controlled with an electronic quality management system, EQMS. The date and time are traced in the audit trail, as well as the signatures of the authorized parties during the document lifecycle. Usernames and passwords should be required to access the documents for critical data entry or review. Whenever an electronic document is modified, the system should record all changes and deletions. When a new version is issued, the EQMS should notify users and provide access to the updated version. Regarding the issuance of blank paper templates, blank forms, for data recording, the system should ensure all printed forms can be reconciled and accounted for upon completion. In addition, appropriate controls should be in place to ensure the integrity of the documents throughout the retention period. This means that only authorized documents should be available. Superseded documents should not be accessible for use. If a legacy computerized system lacks computer-generated audit trails, you may use the alternative means until you replace the system. The controlled use of logbooks, change controls, record version controls, or other combinations of paper and electronic records can be used to meet GXP regulatory expectations for traceability, specifically to document the what, who, when, and why of an action. Special care should be given to GDP training plans in the way of recording data directly in electronic databases. It is improper to record data first in unofficial documentation, for example, on a scrap of paper or post-it, and later transfer it to official electronic documentation, for example, to a LIMS, chromatographic data processor, etc. Original data should instead be recorded directly in official records, either in controlled paper-based analytical worksheets or electronically, immediately at the time of the GXP activity. All data collection and recording performed by a computerized system should take place following risk-based controls to protect and verify critical data. This means the system should apply validated checks to ensure the completeness of the acquired data. For example, manual data entries of critical data, such as the sample identification for laboratory tests, should be verified by the system as appropriate for the intended use of the data. Access to changing clocks should be restricted for recording timed events. Computerized systems should be accessible at locations where activities take place so that the data is recorded contemporaneously and ultimately to avoid a future transcription. Data captured by the electronic system should be saved in a format that is not vulnerable to manipulation, loss, or change. Very important. If people make changes to the original electronic data, the computerized system should associate all changes with the individual or individuals making those changes. In other words, all changes should be time-stamped and a reason for the changes recorded. This is the purpose of audit trails. Users should not be able to amend or switch off the audit trail. Regarding timestamps, the IT department should have procedures and maintenance programs in place that ensure time and date stamps are synchronized across the GXP operations. It is also improper to use backdating or postdating. Instead, the date recorded should be the actual date the data entry took place. Specific control means can be implemented in the electronic system so that accurate recordings of time and date are stamped automatically. For example, laboratory equipment or instruments should be connected to an electronic system for real-time data transfer. Critical data generated in an electronic system should be reviewed by a second person to verify that operations were performed correctly or to determine whether any changes, for example, deletion, modification, or overwriting, have been made. This revision is not required in every record. Its frequency can be based on the criticality of data according to a risk assessment. I recommend describing the review process of critical data in an SOP. There, you can describe what should be reviewed and how it should be performed and recorded. Keep in mind that the review activity should also be documented and recorded. For example, some laboratories review the integration of chromatographic data and the audit trail prior to batch release. This is designed to ensure conformance. If you have a hybrid system composed of data saved electronically and in printed form, both versions should be checked by the reviewer to ensure the printed data is accurate and identical to the electronic data. For example, both paper chromatograms and electronic data should be compared to check for completeness and accuracy. In the case of missing data, the system should prompt an error message. The same applies to out-of-scope results. The system should highlight the result or prompt a message in such cases. These automations are very useful because they help people detect whether information is missing or if errors have been made during entries. Storage of electronic data should include the original data in its entirety and all relevant metadata, including audit trails. The storage system should use a secure and validated process. Both copies and backups of original data should have the same levels of control in order to prohibit unauthorized access to data, changes to data, and deletion or alteration of data. Storing data enables future queries or investigations to reconstruct the activities that occurred in relation to a batch. In the event an investigation is needed, organizations should have a procedure in place for restoring archived data. This procedure should be regularly tested, for example, on an annual basis. What is a backup? A backup is a copy of one or more electronic files created as an alternative in case the original data or system is lost or becomes unusable in the event of a disaster. Routine backup copies should be stored in a remote location, physically separate from the original data, or better yet, virtually in the cloud. Specific environmental controls should be implemented to ensure the protection of records from deliberate or inadvertent alteration or loss. For example, electronic data can be stored in suitable conditions, free from environmental hazards, vibrations, and magnetic fields. Contingency plans and procedures for disaster management and overall data security are highly recommended. In the event of natural disasters, for example, flood, earthquakes, etc., accidents like fire, voltage spike, server crash, etc., or other events such as vandalism, cybercrime, sabotage, etc., all your data could be ruined and your company could be at risk without a contingency plan. Three different plans can be established. Number 1, backup plan. This is a secure backup of all your data located in a secure location, physical or virtual. For better security, data backups are typically spread across different servers. In my opinion, having just one backup is not enough, especially if it is stored on the same premises as the primary data or on the same type of media. The more backup copies you have, the lower your risk of losing your data. It is common practice to have at least 3 copies of your data, meaning the primary data and 2 backups. The backups can be stored on 2 different types of devices or in 2 different storage media, for example, on optical discs, digital tape, or in the cloud. Number 2, disaster recovery plan. This is a plan to restore backup data in the event of a disaster. Number 3, emergency operation plan. This plan unifies the backup plan and the disaster recovery plan. It describes how you will handle data recovery in the event of a disaster. This emergency operation plan should identify the impact of potential losses, maintaining viable recovery strategies and recovery plans throughout. The plan should also ensure the services will continue. The personnel training, plan testing, and maintenance can also be described in the plan. There is no need to say that only authorized personnel can access data repositories. Secure controls must be in place to ensure the integrity of the records throughout the retention period. When an electronic document is updated, it should include the document's revision history and show the changes that were made. All changes should be handled through the change control procedure. Documents need to be version controlled, with superseded versions being obsoleted and removed from current use. In operational environments, Audit trails that capture changes to critical data should be reviewed with each record before final approval. Although data must be maintained during the retention period, it is not usually destroyed. All electronic data can be perpetual. To finalize the recap, it is worth noting that in the scope of 21 CFR Part 11, with respect to records that must be maintained under predicate rules, when people choose to use records in electronic format in the place of paper format, Part 11 would apply. If you're interested in Part 11, view our course about 21 CFR Part 11 on electronic records and electronic signatures. That's all. Thank you for attending this course. I hope you found it useful and that you have learned what you expected. See you in other courses at Scilife Academy to continue your learning journey.